Alright, so in this video, we're going to continue our discussion about factoring, but we're going to take it a step further and talk about a concept called factoring by grouping. Okay, this is a lot tougher than what we've been doing previously because with factoring by grouping, A is not 1. Okay, so for example, when we were doing our homework from last week, we were factoring expressions like this. I said to factor that, we would find the two numbers that multiply to give me 12 and also add to give me 7, which are 3 and 4. And so I can say this equals quantity x plus 3 times quantity x plus 4. Okay, those were pretty simple because a, which is the number in front of x squared, was 1. But now we're going to talk about problems where that's not the case, where a is 2 or 3 or 4. And so that presents its own new problems. Okay, so let's call this example 1. Let's factor y equals 4x squared plus 7x plus 3. First thing you should notice is that a is 4. It's not 1. So when you see a is not 1, you always need to try to pull out a greatest common factor. So basically divide all three pieces by 4. But when you try to do that, we're going to get 7 over 4 is 1.75, which is a decimal, and then 3 over 4 is 0.75, which is another decimal. We don't want that. Only pull out a greatest common factor if all three terms are divisible by that 4. Okay, once you check that and it doesn't work, you're going to start doing factoring by grouping. So the first step, and pretty sure people call this AC method. I'm not sure. I call it factoring by grouping, but you're going to multiply the two outside numbers together every time. You get 4 times 3 is 12. Okay. Once you get that 12, you're going to find the factors of 12, and you're going to see which factor pairs add up to be 7. And we're lucky because it's 4 and 3, the ones we had originally. Okay, so that part's pretty, it's not too bad. We've done that before. The next step is a little bit trickier. Here's what we're going to do. I'm going to rewrite the original expression. I'm going to rewrite it like this. Okay. Before we move on, I want you to ask yourself, is this expression equal to this expression? It's a yes or no. Okay. After looking at it, hopefully we see that yes, those are equal. They just look different. 7x is equal to 4x plus 3x. Those are the same thing. But how did I know to rewrite 7x as 4x plus 3x? Where did I get those numbers from? I got them from right here. Okay, I just took these numbers and I put x's next to them. All right, why did you do that? It looks like you just made the problem a little bit harder. What this allows me to do is split this second piece down the middle like that. Okay, so earlier, this right here is a 3-term expression. This one is a 4-term expression. I can split a 4-term expression into 2 and 2. I can't split a 3-term expression into whole number pieces. So that's why we broke it up. I broke up the 7x as 4x plus 3x. Now that I've done that, I'm going to pull out a greatest common factor from both terms right here. Okay? Both of these terms 1 second. Erase that. Okay. Both of these terms have at least a 4x in them. Okay? What goes inside the parentheses is what I get when I divide 4x squared by 4x. 4x squared divided by 4x is just x. 4x over this 4x is just plus 1. Okay, so all I did is I pulled out a greatest common factor of the two terms that are underlined in yellow. Okay, how can you check to make sure you did it right? If I distribute here and here, I get 4x squared plus 4x, so they are equivalent. What's nice about factors by grouping is when I go to do the same thing on the other side, I know that I have to have an x plus 1 show up on this side because I had it show up right here. That is a rule. So what I do is when I work these, once I get the left side, I immediately write x plus 1 over here. All I have to find out now is what do I divide by to make that happen, and that is a 3 because 3x over 3 is x, and 3 over 3 is this plus 1. Okay, so that's your next step. And I almost forgot, I have to put a plus in between right there. Okay. So again, we have all equivalent expressions that are just looking different. Your last step is to take these two pieces that are on the outside of the parentheses. You're going to put them together inside their own binomial or set of parentheses. Whatever's inside the parentheses to begin with, that is what I put next. Okay, I get a lot of students tell me, well, Mr. Holst, there are two x plus 1s, so I should be putting a squared right there. But that's not correct. The reason we do all this at the end is because this is basically the distributive property in reverse. So for example, if I was wanting to distribute, I would start with 4x and go 4x times x, and then 4x times 1. That piece, those two green arrows I just drew, or green lines, that's this right here. 4x times x plus 1. What I would do next is do 3 times x and then 3 times 1. That's this piece right there. Okay, I know I'm using a lot of colors, but I hope you're seeing that. That's why these two steps result in equivalent expressions, is it's the distributive property in reverse. Okay, so this is your final answer for number 1. Okay. Example 2. Y equals 2x squared minus 7x plus 6. Step 1, try to pull out a greatest common factor. I start to try to divide by 2 because I see a 2 right there, but 2 does not go into 7 evenly, so I'm going to go ahead and multiply my two outside numbers. 2 times 6 is 12. The two numbers that multiply to give us 12, but add to give us negative 7. This might be a little bit tougher. I'm going to go ahead and write all the factors. 1 and 12, 2 and 6, 3 and 4. Now I need them to add up to be negative 7. I know that 3 and 4 add up to be positive 7, but if I'll make them both negative, now they multiply to be positive 12 because a negative times a negative is a positive, but they also now add to be negative 7. Next step, we're going to rewrite this piece as the sum of these two pieces, where I put an x next to each of them. This is the question I get asked a lot. Does it matter the order that these two numbers go in? Could I put negative 3x first, or could I put negative 4x first, or does it matter? It technically doesn't matter. But in this case, I would put the negative 4x first, then the negative 3x, and then the plus 6. Okay, so again, what I've underlined in green, those are equivalent. The reason I put the negative 4x first is because our next step is to split this up. And when I split it up, I have these two together, and then I have these two together. Do you notice that the 2 and the 4 have common factors? So do the negative 3 and the 6. Okay, so that's why I did that. If I put the 3 next to the 2, those don't have any common factors. So in the end, you would get the same answer. But I feel like this is a little bit easier, but it is your choice. Okay, so we split up these first two pieces, 2x squared and negative 4x. They have a 2x in common. That's the greatest common factor. 2x squared over 2x is just x, and negative 4x over 2x is negative 2. That means an x minus 2 has to show up here. This is where it gets a little bit tricky. To make this x minus 2 show up, I have to divide by negative 3. Because negative 3 over negative 3 is positive 1x, if you incorporate that x. And then 6 divided by negative 3 is this negative 2. Okay? So that's why that negative 3 should show up there. All right. And then, like I said, the last step, we're going to take these two pieces here, the things that are outside the parentheses, and we're going to put them together and then multiply that by whatever is already inside the parentheses. Oops, I'll leave it in red. And there is my final answer. Okay, if you're feeling comfortable, I want you to try this next example. This is example 3. If you want to try, go ahead and pause the video and try to work it. And then once you feel like you're finished, you can turn the video back on. Okay, hopefully you tried to do this, but if not, that's perfectly fine. Just keep watching the video. 3 times 4, that's our first step. We get 12. The factors of 12 that add up to be negative 8 are going to be, looks like negative 6 and negative 2. Okay, looks like that works. Now I want you to ask yourself, which number am I going to put first? The negative 6 or the negative 2? I think we need to put the negative 6 first, but again, that technically does not matter. And just so you can see, I'm going to do the opposite. I'm going to put the negative 2 first. So again, those two pieces are equivalent. That's the thing that has to be true when you're working these. We split it down the middle. Now, when you're looking at, give me 1 second here. All right, so when you're looking at these two pieces, and you're looking for a greatest common factor, 3 and 2 do not have any common factors, but the only thing that these two pieces do have in common is they both have an x. Okay, so I can do that. So I'm going to pull out an x. 3x squared divided by x is 3x, and negative 2x over x is just negative 2. Okay? And you can check it. If we distribute this back, we'll get the exact same thing we started with, so we're good. That means I have to have a 3x minus 2 show up right here. That's the nice thing. Okay, this isn't a super easy process, but this will always be true if you're doing it right. These 3x minus 2's. What do I have to divide by to make this happen? This is another tricky spot. I have to divide negative 6x by negative 2 to get that 3x to show up. And you can check. Negative 6x over negative 2 is positive 3x, and then 4 divided by negative 2 is negative 2. Okay. Last step. Put the x minus 2 for the x and the negative 2 together, all times quantity 3x minus 2. Okay. And then we'll do one last example. Call this example 4. And we have y equals 2x squared minus 9x plus 4 again. If you want to try one on your own, this will be the last example in this video. Pause the video now, try it, and then check your answer by resuming the video. All right. 2 times 4 is 8. Factors of 8 that add up to be negative 9 are negative 1 and negative 8. I can write that. Let's see. Okay. I'm going to put the negative 8x first. Now, when I have negative 1x, I can just write negative x because that 1 isn't really necessary. But if you want it there, that's fine. These two pieces have to be equal, and they are. Let's go ahead and split it down the middle. From these two pieces, I can pull out a 2x. If I do that, I'll get, in the parentheses, x minus 4. And then I have to have an x minus 4 show up here. I want you to look here and here. Those are really close to being the same thing. The only thing that's different is the signs are opposite. So what I have to divide by is actually going to be a negative 1. I know that's kind of hard to see because there wasn't a 1 in our problem, but whenever the terms are really close together like that and the signs are different, just divide by negative 1. And like always, you can check by distributing, and we get the exact same thing we had up here. Okay, last step. Put the 2x minus 1's together. I'm sorry, the 2x and the minus 1, all times that common x minus 4. And that is your answer. All right, so that's factoring by grouping. If you're having a lot of trouble or if you want more explanation, email me. We can email and communicate that way. We can set up a Google Hangout or a Zoom chat room. That's completely up to you. Just let me know if you need any help.